And this will be our last tutorial on SQL. In all the previous tutorials, except the first one where we were creating tables, in all the previous tutorials we had been working with one table alone. So either we were extracting information from one table, or we were deleting information in one table, updating information in one table, adding information to one table, and so forth. So in this tutorial we will see how to work with multiple tables. After all, a relational database is a collection of multiple related tables. So unless we know how to work with multiple tables, then the whole point of a database management system is lost. And the heart of working with multiple tables is the SQL operator called join, or the command called join. So we will see how the join operation works and how you make it part of an SQL statement when you're doing retrievals, for example. Now, as with all our previous tutorials, the database that I will be using as an example is the employee being assigned to projects database. But in this tutorial, I will begin a little differently in that I will show you a lot of paper examples first on paper, and then we will transfer to the Access database and look at all those operations in Access. Okay, so I will not keep switching back and forth between paper examples and Microsoft Access. So so the join operation is a way of combining data from multiple tables. Let's look at an actual example. So here you have, let's say, a relational database with three tables. Here's faculty, here's course, and here's offering. Now, before we actually look at combining tables, just take a look at the nature of the content. So in the faculty table or relation, you have three faculty members, and for each faculty member you have the SSN and the name. Then for the course table, you have the course number and the course name. And the offering is, you can have multiple offerings of the same course and so forth. Okay. But so an offering is a particular instantiation of a course. Now let's look at a few characteristics of this table. You can see for offering 1, 2, 3, 4, 5, you have the course number and you also know who is teaching it. Okay. Similarly, for offering 1, 2, 3, 4, 7, you know the course number and you also know who's teaching it. Okay. But for offering 1, 2, 3, 4, 8, you know the course number, but you don't know who's teaching it, and that's not uncommon. A course is offered, we don't yet have an instructor for it, the students sign up, and at some point an instructor is assigned. Okay, so for offering number 1, 2, 3, 4, 8, you don't have a faculty SSN. Similarly, you can see here that for some faculty, so in other words, you have an offering where there is no faculty. The reverse is also true. Look at the list of faculty. You can see that faculty David King 333, all threes SSN, faculty David King has not been assigned to any course. He's not teaching any offering. Okay, so he does not appear anywhere in the offering table. So there are some offerings without professors, and there are some professors without offerings. So this is the general nature of these three courses, rather three tables in the database. And so there are different ways of combining this information. So let's see what those different ways might be. So the most common way of combining these is this last one. Okay, so here it is, show only the faculty who are offering a course along with the corresponding offering. So only when a faculty member is assigned to an offering, you want to see those cases. And there are three other alternative ways of combining information in these three tables. So let's look at each in turn. So we will look at the wording of each of those combinations and look at the output that results from it. Okay, so here's the first one. It says show only the faculty who are offering a course along with the corresponding offering. Okay, so we are combining information in these two tables, faculty and offering, but we want to combine it in a particular way. A convenient way of imagining how this operation works, how this join operation will work, is you have these two tables. Here's table A and here's table B. When I want to combine table A and B, I only want all the records or other instances that show up in both tables. Okay, so I only want those rows where you have a course number as well as the faculty SSN. Okay, so basically I just want these three. All right, so look at the grammar for the statement. Now you have seen the select from statement before when we were doing retrievals. So here the main thing that's different is this join operation. So that's what I'm going to focus on. But let's look at the grammar. First of all, we are saying, starting with the word select, because we are retrieving information. Here select, and what do we want to select? So we want to see the faculty, so show only the faculty. So we have the faculty SSN and we will have the faculty name and the course number. Okay, so notice that the columns that I'm pulling out, all these columns are not all in one table. So the columns that I want are from multiple tables. That's why I need to do the join. If all the information that you want is from one table, you very likely, in most cases, you will not need to do a join. Okay, so now let's see how one would go about combining the two. So we say first combine the two tables. Since these three columns come from two tables, I list the two tables. So from faculty combine with offering, those are the two tables, and then I use the word join. Join is the reserved word that tells Microsoft Access that you are combining the information from two tables. But this is a particular kind of combination which is called the inner join. Okay, so in the inner join you only pick records when this condition is true. Okay, so this is primary key equals foreign key. Okay, that's, remember the referential integrity constraint that we had discussed right at the beginning of the course. So we are saying combine these two tables such that faculty dot faculty SSN, in other words, the column FACSSN from the faculty table, that's what that dot tells you. So here we're telling this column match it with offering dot faculty SSN. So only when these two match, only when these two columns match, pick out those rows. Pick out the rows from these two tables only when those two columns match. So as soon as you say that, do you see that 3 David King will not be picked up, that row will not be picked up, because we don't have a faculty SSN in the offering table that matches 3 all threes. Okay, so they don't match, so we don't pick them up, pick up that row, and hence the output of this join operation is a table that has columns from both tables. Okay, so this is the result. The result is also this result is also a relation. When you join two relations, the answer is also a relation. So the answer has three columns. Two of them are from faculty table, one column is from the offering table, but only three rows are shown up. The faculty who did not have any offering doesn't show up in the output. Okay, so that's an inner join. So this is the general syntax of the inner join. You will say select followed by the names of the columns that you want to pull out from, and then the two tables that you want to combine, and you specify inner join, and then foreign key equals primary key. That's basically the syntax that you're using to combine the two tables. Okay, now let's look at another way grammatically in which you can express the inner join. So just as a to jog your memory, this is how we specified the inner join. We actually use the word inner join. Okay, so instead of saying inner join, here's an alternate way to write the same thing. Do you see it's the same three columns? Pull out these three columns: faculty SSN, faculty name, course number. And again, notice that these three columns are from two different tables. One was the faculty table and the other was the offering table. Okay, so the course number was from the offering table. And now we say from faculty, comma, offering. So these are the two tables from which we are pulling out the information. So we just list the two tables. And now we say where. Notice that in the previous incarnation of the statement. We don't have where. Okay, we had on. Okay, here's where, and then we say primary key equals foreign key. So these are this grammar, this syntax that you just saw here and the previous one, these are alternate ways to specify the inner join, and it's only the inner join that can be written in either of these two ways. And I would be willing to bet that 90% of the joins that you will do when you write SQL queries are inner joins. Okay, so since it is so common, oftentimes we don't say inner join, we just say join. If you only say join or natural join, then we mean this kind of inner join. But just for completeness, I guess I think we should look at the other variations of the join also. So here again, notice we have the faculty table and the offering table. Okay, so notice the nature of the question. It says show all faculty and their offerings, if any. So this if any qualifier is very important. So for the previous question, we said list all faculty and their offerings only if they have offerings. Only if a faculty member is teaching something do you want to show up in the output. But here we are saying list all the faculty and their offerings if they have any. If they don't have offerings, just list the faculty name. Okay, so you would expect that in the output there would be all three faculty members, and for David King there should be a null value for offering. Okay, so you're again combining information from these two tables, but in a slightly different way. So to continue with our graphical representation of this, again we have tables A and table B. We are combining these two information. Remember, in the previous inner join, we had looked at the records that were in both A and B, when the keys matched, the primary key and foreign key. Here we are taking everything in table A and whatever overlaps with B. Okay, so look at the grammar, very similar to what he had for the inner join, just the word is different. So we say select faculty.faculty SSN, faculty name, course number. Notice these three columns are from two different tables. The course number is from the offering table. So just like the inner join, we list the two tables that we want to join. We want to join faculty and offering, but now instead of saying inner join, we are saying left join. And the way to remember this is when we say left join, pick up everything from the left side table. So you're joining one table with another, pick up everything on the left side table. That's why left join. Okay, so everything from faculty which matches offering and which doesn't match offering. Okay, so where faculty.f faculty SSN equals offering.faculty SSN. So this is primary key equals foreign key. Okay, so we start with all ones for John Doe and go ahead and match, and we get this record. Okay, so that's how the first row came out. Then we start with 222 for Maggie Smith, and we go down the entire offering columns. It matches here, so that's the second row. It matches here, that's the third row. So primary key equals foreign key. Okay, so now we come to 3333. We put it in the output and we go down the offering and we find no matches. Okay, so we have a null value for David King. But notice that this offering 320 for 1, 2, 3, 4, 8, that didn't show up in the output. Okay, because it has no faculty member assigned to it. All right, so I hope you saw what the left join, how the left join works. Now I'm going to show you how the right join works. Once again, you have two tables, faculty and offering. So here's table A, here's table B. This time we are picking up the rows that match and all the rows from table B that don't match. Okay, so what would be the wording of the question that would allow that would let us would make us write a right join? She said show all offerings and the assigned faculty, if any. So here I want the list of all offerings, And if there is no faculty member assigned to it, I just show a null value for the faculty. Okay, so here you say select faculty name, course number. Again, 3 columns from 2 tables. This column is from the offering table. Again, we say faculty and offering. These are the 2 tables to be joined. But now we say right join. All that means is telling Microsoft Access that pick up everything from the right side table. So of this listing, faculty is on the left, offering is on the right. So we're saying pick up everything from the right, okay, that matches faculty, and if it doesn't match, that's fine also. Okay, so our starting point will be offering. So we start on the first row, offering, and we have faculty SSN here 1111. Okay, so I go down this entire list, and 1111 is John Doe, so I put John Doe in the output, and there's the one. Okay, now I come to 2222. Then I go down the faculty list and it matches Maggie Smith. So here's the second. Okay, so now I pick up the third row over here, and the faculty SSN is all 2s. So again I go down the faculty list, and again it matches Maggie Smith. So here's the third row with the course 310, and now I come to the last offering, okay, which is course 1, 2, 3, 4, 8 and MIS320. Do you see I pick up the course offering, and then the value for faculty SSN is null, so obviously it's not going to match anything on the faculty table. So I just write null for the faculty name and for the faculty SSN. So I picked up everything on the right hand side table, whether or not it matched the key on the left hand side. So that's your right join. Okay, and the last variation is what's called the full outer join. Okay, so here is the question, says show faculty and offerings regardless of whether the faculty is offering any course or whether the offering has a faculty assigned to it. So in terms of our pictures, it picks up, we want to pick up all the records where the keys, primary key and foreign key, match both, and the ones in table B that don't match, and the ones in table A that don't match. Okay, so the grammar is very much the same. The only difference is full join instead of right join or left join. Okay, and the output looks like this. Okay, so if you have a faculty member who is not teaching a course, this one, the course number shows up at null. If you have an offering for which there is no faculty member, the faculty SSN and the faculty name shows up as null. Now, I'm not spending too much time on full join because Microsoft Access cannot execute a full join. SQL Server SQL can, but Microsoft Access cannot, so I'm not spending too much time on this fellow. Okay, so I'm going to now show you some actual examples. So you're going back to the employee table. So remember, in our example database, we have departments with employees. Employees are assigned to projects. One employee can be assigned to many projects, and one project could have multiple employees assigned to it. Okay, so here is the relational database as before. So let's look at joins here. So let me scroll down a little bit here. All right, so here's the question that we are proposing. Show only the projects who have been assigned an employee along with the corresponding employee number. So table A is the projects table, table B is the assignment table. Okay, so we are, do you see, here's the project table and here's the assignment table. These are the 2 tables I want to connect. Why do I need to connect? Because look at the information that I want. I want the project ID, I want the project name, and I want the employee number who's working on the project. Okay, so obviously if I look at these 3 columns, all these 3 columns are not in one table. They are in 2 different tables. The project name and project ID are in one table. The employee number is in an employee table, rather is in an assignment table. So I have to connect the 2. I have to join the 2 tables. Anytime you are extracting columns that come from multiple tables, you have to do joins. That's basically the rule of thumb to remember. Okay, so I want to here let me show you the two tables. Here's the employee table, here's the project table, and here's the assignment table. So let me open the project table, and here is the assignment table. All right, the project, assignment. So I want, look at the information that I want. I want the project name and the employee number, okay, for all projects. So if you go back to the database, so if you look at the assignment table, do you see you have the employee number, you have the project ID, but you don't have the project name. To get the project name, I have to start from the assignment, find out the project ID, go back to project, and from the project ID find the project name. Okay, that's why you need to join the two. And obviously I want to find the names for those assignments that have where the project number is known, so where the primary key equals foreign key. So you look at project and assignment, I want those records where the primary key matches the foreign key. Okay, so assignment has a composite primary key, remember. So project ID in assignment is a foreign key. So let's see what the grammar is here. So look at what we have written. We say select project dot project ID. Why did I have to write project dot project ID? Because if I look at the two tables, project ID shows up in both tables, isn't it? Project ID shows up here and project ID shows up in assignment. So unless I tell Access which table I want the project ID from, it's going to get confused. Okay, so I tell it project dot project ID, project name, and employee number. The two tables that I want to connect are project and assignment, and I say do an inner join. That simply means only pick out those rows from the two tables where the foreign key exactly matches the primary key in both tables. Okay, so on project dot project ID equals assignment dot project ID. So this is your primary key, this is your foreign key. Okay, so both must match, the two must match, and only then I will pick out the row. So let me copy this, copy this SQL command over to, let me create is the SQL view, paste. Okay, so when I run this query, the answer that I get should be another relation that has 3 columns, because I said select project ID, project name, and employee number. There should be 3 columns, and you can see that these 3 columns come from 2 different tables. That's why I needed to do the inner join. Okay, so let me run this, and there you are. You have the project ID, the project name, and employee number. Okay, so do you see that the first column and the third column came from one table, namely the assignment table, and the project name came from the projects table? That's why I had to do the join, but this is an inner join. Okay, if you can see by going down the list, you can see that only those records where the primary key matched the foreign key have been picked up. Okay, now we are going to, let me go back to the SQL view, and I'm going to delete this fellow and look at a slightly different query over here. Okay, so now I want the project ID, the project name, and employee number for all projects, whether or not an employee has been assigned. Okay, so let me delete this and write down the query itself. List the project ID, project name, and number for all projects whether or not whether or not an employee has been assigned to the project. Do you see that this question is slightly different from the previous one? Okay, so think back to the previous one. The previous query said list the project ID, project name, and employee number for all projects to which employees have been assigned. Only when an employee has been assigned to a project, you only want those listed. Okay, here we are saying list the project name, and the employees who have been assigned to the project, whether or not there are some projects to which no employee has been assigned, and I want those in the output as well. So I'm doing a left join. So do you see project, assignment? Those are the two tables that are being joined. The project table is on the left, assignment table is on the right. So whenever you say left join, you're saying pick up everything from project along with whatever matches assignment. If there is something in project that doesn't match assignment, still list it. Okay, all right. So just to refresh your memory, so here's so okay, I deleted that, so we don't have it. Let's take this query, copy, paste. Okay, let me run this. You see that the output looks pretty much the same as before, but when you get to the end, you see these three projects, 2500, 2600, 2700. Okay, these are projects to which no employee has been assigned yet. If you look at the assignment table, do you see that those three projects do not show up on the list of assignments? So no employee has been assigned to those three projects yet. When I want the output, I want those projects listed with their names. It's just that nobody has been assigned to those projects yet. And I got that listing by using the left join. All right. So now I'm going to do a slightly different version. Now I'm going to do a right join. Remember, I told you that Microsoft Access cannot do a full join. So here is a slightly different query now. Right join. So let me also write the in English version what is the query that I'm asking. So I want list the employee number, employee first name, and project ID of all employees, whether or not they have assigned to a project. So there are some employees who have not been assigned to a project. So what I'd ask you to do is just think through the wording of these three queries. All three queries involve projects and employees, but the wording is slightly different. And when do you use an inner join, and when do you use a left join, when do you use a right join? It takes a little getting used to. Just think through the wording of these three queries, and it should be fairly clear as to when to use the left or right join. So notice that we use the right join. Here are the two tables. One is assignment and the other is employee. Okay, so anytime you see the right join, remember what we did for left join. When we had a left join, we picked up everything that the left side table had along with whatever matched on the right hand side. So when we say right join, our starting point is the employee table, and we are saying start from the employee table, combine it with everything that matches in the assignment table, and if there are any employees left over who don't have any assignment, still list them as well, okay, without any assignment. So on employee.employee number equals assignment.employee number. If you look at this expression, you can see that this fellow is the primary key, this fellow is the foreign key. So primary key equals, so whenever you're doing a join, this primary key equal to foreign key is sort of is fundamental of doing the join. So let me go back to Access, and I'll copy this query over, copy, and here we go, paste. And when I run it, do you see that there are some employees like Rosalie, George, Alan, James, Rick, Mike? They have not been assigned to any project. So if you did an inner join or you did a natural join, the 90% of the time the join that you do, these names wouldn't show up because they have not been assigned to any project. But the nice thing about this particular output is you can not only see which employees are working on project, you can also see which employees are idle because they haven't been assigned to any projects, and that can be useful for managerial purposes. All right. Okay, so I've shown you how to do inner join, left join, and right join in Access. And remember, I told you that Access cannot do full join. You can do it in SQL Server, but not in Access. So for as far as full join is concerned, you just have to go with the paper example that I showed you several minutes ago. So I will end this tutorial with a query that requires joining 3 tables. All right, so if I join 3 tables, I will need 2 joins because a single join can only connect 2 tables together. So here it says list the project name, employee last and first name, and hours worked for all projects and employees. Okay, so if you think of the information that's being requested here, the place to start is the relationships diagram. So you have to ask yourself, how many tables do I need to work with to answer this question? Okay, so if you look at the wording, it says list the project name. That's one of the pieces of information that I need. So where is the project name? The project name, the only place where I can find the project name is in the project table. So I know I at least have to extract the information from the project table. Okay, so what else do I want? I want the employee first and last name. Okay, so the employee first and last name can only be found in the employee table. So I have to get information from the employee table as well. But there is no way for me to get from project to employee directly. The only way to get from project to employee is through the assignment table. And besides, the question also asks me to get the hours worked. Okay, so the hours worked can only be obtained here. So if you think of the pieces of information that the question is asking you to retrieve, they are in 3 different tables. If they're in 3 different tables, they have to be joined. And since you can only join 2 tables using a single join operation, you will need 2 join operations. One to go from project to assignment, the other to go from assignment to employee. So let's see how you would write that. You would say select from where, just as before. So after the word select, you would list the columns that you want to extract. So I wrote project name, last name, first name, hours worked. Now notice that I didn't put the names of the relations before these column names because there is no ambiguity. Project name shows up in only the project table, so there can be no ambiguity about which table I'm referring to extract this information. Similarly, last name, first name can only be found in the employee table, so I don't need to put the name of the relation. Same with hours worked, it can only be found in the assignment table. Anytime you have a column that shows up in more than one table, you have to qualify that column name by the table name, otherwise Access is going to get confused. After the word select, reserved word select, I'm telling Access that this information can be found in these 3 tables: project, assignment, employee. And since there are 3 tables, I have to have 2 joins. So here's the first join, and here is the second join. Okay, and each join, the nature of each join is primary key equals foreign key. Right, go back to the diagram here. Here's the primary key, project.id equals project.id in assignment. So primary key equals foreign key. Similarly, primary key equals foreign key. Okay, so there you are. Primary key equals foreign key. That's the first link. Here's the second one. Primary key equals foreign key. All right, so now I'm going to copy this over to Access. Copy, and where are we? Let me get the SQL view, and I got to delete this fellow to clean up my box here in which to put the query. So paste, and I run it. So there you are. You have the name of the project, which is from the project table. You have the employee last and first name, which is from the employee table, and you have the hours worked, which is from the assignment table. So this one table in the output contains combined information from 3 different tables in the database, and that's what the beauty of a relational database is. You have information in connected tables. The tables are connected to one another, they're related to one another through foreign keys, and you combine that information using joins. Okay, so this concludes our current tutorial on how to extract information from multiple tables using joins.